So we're starting our next unit on similarity, and so that's what we're going to talk about today is similar polygons. And your learning target is I can identify and apply properties of similar polygons to solve problems. So first we're going to go in and we're going to define similar polygons, and to define that we're going to say that polygons are similar if their corresponding angles, so their angles, all their angles are congruent. If their angles are congruent, and that the corresponding side lengths, so those side lengths that are similar to each other, as long as they are proportional. So let's go into that key concept, how do we solve, how do we see if two figures are actually going to be similar? And the first thing we need to do is check to see if all the corresponding angles are congruent. If all of the angles are congruent, then we're on the right step to proving that these two figures are similar. Okay, the second step that we have to take is that if the corresponding angles are congruent, then we need to check to see if the corresponding sides, those side lengths, if they're proportional. Okay, and the last thing right at the very end is if we found that the angles are congruent, the sides are proportional, then the polygons are similar. So the main things that you have to do to figure out if two figures are similar, we have to find all the corresponding angles are the same and all the corresponding sides are proportional. So let's take a look at an example of this. Example 1 says that we need to determine whether the polygons are similar, and if so, write the similarity ratio in similarity statement. Okay, so this first one right here, remember the first thing we're supposed to do is we're supposed to try to figure out if all the angles are congruent. And we're given two rectangles, okay? I know it doesn't say it right here, but in the problem it states that these two shapes are rectangles. And so what we know about rectangles is that all the angles are 90 degrees. So that all the angles are the same, which is a good first step. And now that we've done that, we need to see if all of those sides, the corresponding sides, are proportional. Okay, so we know we need to identify what the corresponding sides are, and we see AB is going to be corresponding to EF. So AB is corresponding to EF, and we also know that BC is corresponding to FG. Okay, now we don't have to do the other two sides because this is a rectangle. It's going to be the same side lengths no matter what. Okay, so now we need to write in those ratios, the ratios of the corresponding sides. So from this shape 1 to this shape 2, we're going to write ratios. Okay, and AB is 6. Remember, ratios are just fractions, and EF is 4. So we're writing these ratios down, and we want to make sure that that is equal to, that proportion there, that fraction is equal to BC to FG, so 9 to 6. Okay, now these aren't the same right now in terms of just the overall fraction, but we can reduce both of these, and 6 over 4 reduces to 3 over 2, and we see 9 over 6 also reduces to 3 over 2. And so because they have the same ratio, in terms of the side lengths are an equal proportional ratio, then what we can do is we can say that rectangle ABCD is similar, and that's the symbol for similar, is this little squiggly line. It's the same little squiggly line that we had for congruent, except we don't have those equal signs under it. Is similar, to rectangle EFGH. Okay, so we're just proving that those two shapes are similar because all the side lengths are proportional and all the angles are congruent. Now the second part to it, it gives us two triangles, and we see that these two triangles here are isosceles triangles. And remember, the first step we need to do is to figure out if the angles are congruent. And because we know this is an isosceles triangle, we know that angle W is going to be 62 degrees. And so angle T, that vertex point, should be also 36 degrees. And if we add these up, we know all the angles in a triangle add up to be 180. So 62 plus 62, that's 124. And 180 minus 124, we're going to solve that. We end up seeing that's 56. So angle T is 56 degrees, which means that because these angles are not the same, because they're not congruent, that these two shapes, triangle PQR and STW, are not similar. They're not similar. All right, example 2 has us with these race cars, okay? And we're trying to find the length of the model to the nearest tenth of a centimeter, okay? So what it's saying essentially is that this model was built based on that racing car. And we know that the dimensions just need to be proportional then, okay? So we first need to write the ratios that are given. We know the width of the car is 1.8 meters. And we can put that over the same width of the model, which is 6.3 centimeters. And that needs to stay equal to, it needs to stay proportional to the length of the car, which is 5 meters, over the length of the model, which is X centimeters. We do not know what that distance is. Okay, so what this is this is just solving a proportion. And when we solve proportions, I like to use the cross product rule, or I call it the golf club rule, because we know cross product means that we have to multiply the opposite sides of each other and multiply those and set it equal to the opposite of that. So 1.8 times x is just 1.8x is equal to 6.3 times 5. Well, I'm no mathematician, but I know that I have a calculator and a friend to use, so I'm going to do 6.3 times 5, and I get 31.5. And then we just have to divide by 1.8 on both sides. And that will end up getting x by itself. Again, I don't know exactly what that is, so I'm going to get my friend out, divide by 1.8, and we get 17.5. So x, which is the model, the length of the model is 17.5 centimeters. All right, that's it. Enjoy.